Welcome, math lovers. So we'll continue to do some interesting questions on NCR, NPR, linear and circular arrangements today. Question one. The question is the number of 10-digit numbers that can be written using the digits 1 and 2. So they want to make 10-digit numbers, but it should be made only using the digits 1 and 2. Okay. So here we'll take the condition with the help of digit 1, the presence of digit 1. So if suppose digit 1 is going to be present 10 times, there's going to be only one number in that. Suppose digit 2 is going to be present 9 times. Sorry, digit 1 is going to be present 9 times. Then we can understand 2 has to be present for only one time because it's a 10-digit number. So 2 can be present in any of the 10 positions. So I can write it as 10C1. So similarly, digit 2, so digit 1, if it's going to be present 8 times, so from there we can understand the remaining two digits have to be digit 2. It has to be present twice. So which two places we can write as 10C2. So like this, we can take it forward. So finally, we can write like digit 1 present 0 times. That means all the places, all the 10 places are filled by digit 2 itself. So that will be 10C10. So all these are our success cases. So we need to add the total number of things. So this one over here can be written as 10C0 as well. So 10C0, 10C1, 10C2, so on till 10C10. But you would understand this 10C0, 10C1, we learned in the first class about the NCR's addition in any particular row of Pascal triangle will create a power of 2. So this will create 2 power 10. Okay. But now you have to be careful about the condition. The condition is the number of 10-digit numbers that can be written using the digits 1 and 2. They have used the and condition. So meaning you cannot make a number which is fully filled by 1 or fully filled by 2. So those two will be called as the failure cases. We need to remove them. So our final answer should be, we will be removing the number which has all ones or all twos. So 2 power 10 minus 2 will be the right answer. So students do get till here, but they forget to subtract 2 because they are the failure cases. So let's move on to question number 2. The question is, how many 3-digit even numbers can be formed using the digits 1, 2, 3, 4, 5, 6. Repetition is not allowed. Okay. So it's very clear. It's an even number that we are looking out for. So there are only 3 cases that's going to be possible. Case 1, you can have numbers ending in 2. Case 2, you can have numbers ending in 4. Case 3, we can have numbers ending in 6. And digits are not allowed to repeat. Now in case 1, except the digit 2, there are 5 other digits. So 5 ways to, so from those 5 digits, you have to pick 2 digits. Okay. So 5 ways to fill this and 4 ways to fill this. It's an ordering also. Order also matters. So it'll be like, I can write it as 5P2. Same thing would be applicable here. This will also be 5P2. This will also be 5P2. So these 3 are individual success cases. So finally, we will add our answers. So NPR formula we have all learned. It's n factorial by n minus r factorial. So this is going to be giving us 5 factorial by 5 minus 2 factorial. So 5 minus 2 will be 3. So 3 factorial. So 5 factorial by 3 factorial will give us 20. So it will be the same answer. 20, 20 and 20. So altogether it becomes 60. So people who don't want to use this NPR formula thought here, they can easily understand it as 5 ways to fill this number because you cannot repeat the digit 2 again. And since now 2 digits are already being used, so 4 ways for this. So 5 into 4 creates this number 20. Okay. So we're going to question number 3, people. So Tn denote the number of triangles that can be formed using vertices of a regular polygon of n sides. They are saying if Tn plus 1 minus Tn is equal to 21, what is the value of n? Okay. So to create a triangle, you will be requiring 3 vertices. So Tn plus 1 denotes a regular polygon having n plus 1 vertices. So from n plus 1 vertices, you need to choose 3 vertices to make a triangle. Tn represents number of triangles that you can make from a regular polygon of n vertices. So from n vertices also, you need 3 vertices to make a triangle. So n plus 1 C3 minus n C3 is going to give us 21 according to the question. So we'll try to solve this. So we know the NCR formula. So using that, this will be n factorial by 3 factorial into n minus 3 factorial. This will be n plus 1 factorial by 3 factorial into n plus 1 minus 3. That will give us n minus 2 factorial. This is equal to 21. So out of these two factorials, if I compare n factorial and n plus 1 factorial, n plus 1 factorial is a bigger number. So I can rewrite it as n plus 1 times n factorial. Okay. And this 3 factorial be as it is. Comparing between n minus 2 factorial and n minus 3 factorial, I understand n minus 2 factorial is the bigger factorial. So I can rewrite it as n minus 2 times n minus 3 factorial. So minus n factorial. So why are we doing this? So that we'll be able to take the factorial parts common. Okay, so at the moment, I understand I can be taking this n factorial by 3 factorial common. Okay. So what I'll be left out with, I'm having n plus 1 by n minus 2. And also I have this n minus 3 factorial common. So I'm left with n plus 1 by n minus 2 here. And here, just 1 by 1. Because everything you have taken common from the second term. Now let's expand this. Let's see what we get. So I get n plus 1 minus n plus 2 divided by n minus 2 within the brackets equal to 21. So plus n minus n got cancelled off. So n factorial by n minus 3 factorial into 3 factorial. 3 factorial value is 6. And cross multiply it will become into 6. And here on the numerator you have 1 plus 2, that is 3. Cross multiply, it will become 21 into 6 by 3. So finally we are left out with n factorial by n minus 3 factorial into n minus 2. So n minus 2 into n minus 3 factorial is there. So that will become n minus 2 factorial. And n factorial I can rewrite it as, because for solving these kind of questions, you should not be allowing factorials to stay. You should cancel them out. N factorial can be written as n times the previous number, n minus 1, the previous number, n minus 2 factorial. So that you will be able to cancel this term and this term. So this comes out to be on cancellation 3 7s are 21. So 7 6 are 42 comes. So we exactly got the form. 7 into 6 is there on this side, and n into n minus 1 is there on this side. So it really matches up because 7 into 7 minus 1, that's 6. We got the value of n, which we are asked to. So n equal to 7. Okay. Thank you, people. We'll meet in the next session and share more interesting questions. Like, share, and subscribe.